use the fundamental theorem of calculus to find the derivative of the following function g of x equals this stuff here. Okay, that looks like quite a bit. Taking the derivative of this thing. Well, I don't even know what the integral of this thing is. So how am I supposed to take the derivative of that thing? Fear not, we can use our tools, namely fundamental theorem of calculus, to make this thing a little bit easier. We don't actually have to do a whole lot of calculations. We just have to know what we're talking about. So, step one. Good Lord, this problem looks tough. Step two, recall that the fundamental theorem of calculus says that if you want to look at the integral of some function f of x from a to b, that is the area of this function f of x, all you have to do is find some antiderivative of little f, we'll call that big F, and it's any antiderivative. There's always an infinite number of antiderivatives, by the way, because you can always add on constants. Anyways, if you find any antiderivative of f, it turns out that the area between a and b is actually given by the antiderivative evaluated at b, take away the antiderivative evaluated at a. That's pretty powerful, okay? Because usually to compute integrals, if we follow the definition of an integral, we have to use Riemann sums. And that's really annoying, especially for something like this mess. Imagine doing that in Riemann sums. That'd be just a complete mess. Let's do this shit. So, this thing, let's just use the fundamental theorem of calculus. This is part 2, although depending on your book, it might be part 1. In any event, if we get, we're just using the fundamental theorem of calculus. It says that find the antiderivative, plug in the top thing, and then subtract the antiderivative plugging in the x. So that's what I did. And I'm just saying where f at x is any antiderivative of that. I don't know what the antiderivative of this thing is off the top of my head. Okay? So, but it doesn't matter. I'm just going to say it's f whatever, okay? Now, let's take the derivative of this shit as that's what we're after. The reason why I don't really care what the antiderivative is, it's because we're going to be taking the derivative of this stuff. Remember, the question is asking, find the derivative of the following function. Not find the integral. The fundamental theorem of calculus here is helping us find out the integral. Okay? We want to now take the derivative of this thing. And we're going to use the fact that derivatives of antiderivatives just return the original function back. Okay, so let's take a peek. So now I'm going to derive both sides of this thing here. Okay? Because that's what they're asking me to do. Take the derivative of this. Well, we know that taking the derivative of this is just the same of taking the derivative of this. So that's what you see here. Derivative of this side is equal to derivative of that side. Now remember that derivatives split over sums and differences. So if you have the derivative of this difference, it's equal to the derivative of the first part. Take away the derivative of the second part. And that's what we have down here. So derivative of this part minus that part. I write that back up here. I don't do anything at all, just so we can follow it more easily. Now, an antiderivative of this thing evaluated at 1. What's that going to be? That's going to be a constant. It doesn't matter what the antiderivative of cosine 5th root of t is. It doesn't matter what it is, because once I plug in 1 for that value, for that t value, it's going to be a constant. It's going to be some constant. If you take the derivative of this constant with respect to x, that's like asking how much does that constant change as I start to increase x? And the answer is 0. That's why the derivative of constants is 0. So I'm left with the second part here, which I'm just going to rewrite there. And this part is 0, so that's why it's gone. Now, the derivative of an antiderivative just returns back the function. That relationship between derivatives and antiderivatives is very nice, and it's very obvious that if you take derivatives and then antiderivatives, you get back more or less exactly what you started with. Okay? If you take antiderivatives and then derivatives, you definitely get back what you started with. Okay, and then the only thing that's different is that we have this minus sign here. Okay? That's the only thing that's different. If it was switched, if it was a 1 down here and an x up top, then it would be positive. It would be positive cosine this. And you could follow the exact same thing through. You would see that this one here would be the f at x, and this would be the f at 1. And so you'd be having the regular function minus 0, so you just get the regular function, the positive version of it. Anyways, there you go. That's evaluating this using the fundamental theorem of calculus. I hope that helps. I hope that makes sense. If you have any other questions, let me know. Of course, email me, tallguytutoring@gmail.com. I can help you out. I can help teach this course. Yeah, we'll talk to you guys later. Pieces.